Okay. My video part isn't working, so we're just going to have a video today. Okay, so today we're going to talk about how to multiply and divide rational expressions or functions. Involves a lot of factoring and a lot of canceling of terms. So once you get past the factoring aspect, it's actually really easy, but that's why we made that foldable on Friday, so that you will know how the different types of factoring that you could use. Okay, so let's get to how we do this. So the steps. So steps for multiplying and dividing rationals. So remember that a rational function is one that's 1 divided by x. Okay, so we're talking about fractions. So when we talk about fractions, we always want to have the smallest fraction possible. So to do that with rationals, we're going to have polynomials divided by polynomials. So what we're going to do is first factor the numerator and the denominator completely. Okay, so you want to make sure it's in its simplest form to start. Then you're going to cancel common factors up and down and on the diagonal. Okay, and this will make more sense here in a minute when I do an example. Alright, then to multiply, we multiply items straight across. To divide, you flip the second, then you multiply straight across. Okay, so these are the steps. Make sure you write this down. If you need to, pause the video right now and write those down. Okay, and here we go to example 1. Now, example 1 is a special instance where you don't have to factor because they're just monomial divided by monomial. Okay, we're multiplying, so we know that we're going to multiply straight across. So to start, I'm going to go ahead and multiply straight across. So 2 times 15 is 30. Okay, x to the 4th times x squared. Remember, you add your exponent, so I have x to the 6th. The y doesn't have anything to combine with, so it's just going to stay y to the 5th. Okay, then you do the same on the bottom. 3 times 8 is 24. X squared times x cubed is x to the 5th. And then I have a y squared. Now, at this point, we still want to simplify this because that way we have the smallest fraction possible. Okay? So if you remember back to your exponent laws, exponents subtract and numbers will just divide. So 30 and 24 each have a 6 in common, right? So this could be divisible by 6, which would make it a 5. This would be divisible by 6, which would make it a 4. And then, so we would have 5 over 4, x to the 6th divided by x to the 5th. You have 6 minus 5, so that would leave 1x. Then 5 minus 2 would be 3, so I would have y cubed. So this would be the answer to my simplified fraction. Okay? So that's a special case with just dividing monomials. Now, if you have things that have polynomials, meaning they have terms like this, then you have to do a little bit of work. Okay, so I want to factor every single piece individually. So what a factored form means, I either have 2 parentheses sets, or I take out what they have in common, or whatever is happening. Okay, so let's do the top part first. So this is a trinomial. So if you look at your notes from Friday, you have to use the M&A method when you do that. So my M for this one is -6. And my a is -1. Okay, so I have to add to -6 and multiply to -6 and add to -1. So I'm going to use -6 and 1, right? No, scratch that. I'm going to use -3 and 2 because -3 plus 2 is -1. -3 times 2 is -6. So I'm going to go ahead and do it down here. So I should have x minus 3 and x plus 2. Now, remember, if there's a number in front of the squared term, you then have to divide each term by 2. We haven't done that in a while, so that's a good example. Okay, when that happens, remember this just becomes a 1, so I would have x plus 1. Over here, it doesn't divide evenly, so remember it goes back to the front. So I'd have 2x minus 3. Okay, so now I factor the top portion. Then we're looking at this one, okay? Well, it's adding, so it's not difference of squares, but if I look, they both have an x in common. So what I can do is the greatest common factor would be x. I would just pull it out to the front, and I'd be left with x plus 1. Okay, so now this fraction is fully simplified, or factored. Times, okay, let's look at the top up here. Again, we're adding, so we don't have difference of squares. We only have 2 terms, so the only thing I can do is pull out what they have in common. So they both have a 4 and they both have an x. So I'm going to have 4x and be left with x plus 1. Now at this point you should start to realize things are starting to match up, which makes sense because we're going to start canceling stuff here in a second. Okay, and then I have 2x minus 3. Nothing can happen to that. At this point, this was step 1. Now we're doing step 2. We're going to cancel. We cancel up and down and on the diagonal. So even though this x plus 1 and this x plus 1 match, I can't cancel them because they're straight across. Okay? So I know that the 2x minus 3 and the 2x minus 3 are going to cancel. This x plus 1 with this x plus 1 is going to cancel. Okay, I have an x here and I have an x here, so that's going to cancel. So the only thing I have left is 4 and x plus 1. So I would have 4 x plus 1 would be my solution. Now I know that's a lot. That's the reason we're taking this slow. Let's do a third example. Now in this case we have division. So division, you're still going to factor all of this stuff out, but you have to flip the second fraction and multiply instead of actually dividing. So what I'm going to do, I always do that first so I don't forget. Okay, so this one stays the same. Change it to times and flip it so that you don't have to do it at the end. Okay? Then what you're going to do is factor each of the pieces. Okay? So let's start here. So I have x squared minus 16. There's two terms. It's subtraction. They're both perfect squares. I know that I'm going to factor it to x plus 4, x minus 4. Ooh, 4. Okay? Again, remember that's why we did that foldable on Friday. X minus 9, nothing can happen with that. It's going to stay the same. Okay? On the top part, I have 3 terms, so I have to use the M&A. So what multiplies to negative 90 and adds to 1? Okay, well that would be a positive 10 and 9, negative 9. Okay? So on top, I'm going to have x plus 10, x minus 9. Now if you notice, look, again, x minus 9 match up. Well, because we're canceling stuff, most likely you should have things that appear. So if you're given a binomial here that's already factored, most likely it should appear on top somewhere too, so it'll cancel. And that kind of gives you a hint of what number you should have. Okay, for the bottom one, my multiply is 40, and my add is 14. Okay, so 40 would be 4 times 10, which would add to 14. So I'm going to have x plus 4, x plus 10. Again, 40, it could be 8 and 5, it could be 2 and 20, but I already have an x plus 4 here, and I have an x plus 10 here, so most likely those are the numbers I should be using. Alright, so use your clues within your problem to get your factored forms. Okay, then we already flipped it, so we don't have to flip it. It's already been flipped. We're just going to cancel things out. So x minus 9's cancel. X plus 4 cancels, x plus 10 cancels, and the thing that I'm left with is x minus 4, and that would be my answer. Okay, so it's a lot of work, yes, but the hardest part of it is factoring. Once you get past that, it's really simple. Okay, so you have an entrance ticket. Here's a problem. It's multiplying, so you're going to factor the top, the bottom. You're going to multiply and you're going to get an answer. I will be checking for this along with your notes, not just this problem, for a grade on Monday. Okay, so let's start the 6 weeks right by getting a good grade by watching our video. Okay, again, if you're still confused, rewatch the video and take good notes. Write down any questions you may have. Okay, have a good day.